And as you can see by looking at your handout, standard enthalpy of formation is given that symbol, delta HF with a little degree symbol. Y'all already know what the delta H part means, right? That's change in enthalpy. The F stands for formation. In other words, it's the formation of a compound from its elements. What elements make water? Hydrogen and oxygen. Okay, so it would be looking at the reaction of hydrogen and oxygen to make water. What elements make sodium chloride? Sodium and chlorine, right? So it's looking at how much energy was required for sodium and chlorine to react and make sodium chloride, etc. That's what the F means. The degree, go ahead.
Is it the
formation of an element? That's actually in the definition. Formation of a compound from its elements. The F just stands for formation. The little degree symbol represents standard states. So that's talking about 1 atmosphere and 25 degrees Celsius. Y'all, that's what we're at right now. Okay, we're at 1 atmosphere sitting in this room, 25 degrees Celsius. The actual values of the standard enthalpies of formation are found in the back of your book in Appendix 2. So y'all look that up. How do you calculate standard enthalpies of reactions? And those are usually written like this, a delta H of a reaction, okay? And a lot of times you'll see that degree symbol up there. But that's going to be calculated using the standard enthalpies of formation. The second box on your handout talks about a standard enthalpy of reaction, and it says there's 2 different ways to do it. One is basically products minus reactants. Your book will call that the direct method, products minus reactants, and it's really easy. The second way is to use Hess's law. And then I also go on in there on your sheet and remind you that if the delta H of the reaction is positive, what does that mean?
It's absorbing.
Right. It's absorbing heat, so it would be called endothermic. Remember that. And if the delta H of the reaction is negative, what do we call that? We call that exothermic. Okay, so remember that. And now, let's look at number 1, the direct method. The direct method says on your sheet there that it uses the formula that the delta H of the reaction is equal to, what does that little funny E mean? Sigma. What does sigma mean in math? Means what? It's a fraternity. Yeah, in what does it mean in math?
You have numbers of
Sigma means sum of. What's omitted from that little formula there is there should be a little M here and maybe a little N here, or a little X and Y. So that formula is what we're going to use to calculate standard enthalpies of reactions using the direct method. It looks kind of ugly, but it's not that bad. So let's look on your sheet. I give you an example reaction. So for this reaction, we're going to use that formula to calculate what is the standard enthalpy change of this reaction. The first thing we have to do is we have to use that appendix that we're on, and we have to look up each of those substances in the appendix and write down what their standard enthalpy of formation is. So y'all work on that. Try to find them and write down the value underneath each one. Okay, so those are the values that we found by looking them up in the appendix. Now, if you recall, that's the heat required to make 1 mole of each thing. Like 49.04, that's for 1 mole of benzene. Negative 393.5, that's for 1 mole of carbon dioxide. So what do you think we need to do next? Yes, we need to take each one and multiply it by its coefficient. And I'm going to go ahead and write the coefficients in over here just to be thorough. Y'all are good on those numbers?
And That's the amount of heat required. How can it be negative?
Because it gives off heat. For CO2 to form from carbon and oxygen, it actually releases heat for that to form. That's what it's saying. Remember, negative is direction. Okay, guys, we're working through this formula. So what we have done is we have looked up the standard enthalpies of formation. When we just now went in, that was number one, to look up the standard enthalpies. Number two, we multiplied them by their coefficients. That took care of this little m and this little n. That's what those are referring to, the coefficients. What do you think we need to do next? Sum them up. The next thing you need to do is sum up the reactants and then sum up the products. After you sum them up, what's the last thing you think you need to do? Subtract. Products minus reactants. So products minus reactants would be the negative 3,218.4 minus the 49.04, and I get negative 3,267.44 kilojoules per mole. Can y'all see that number on the thing? That's the final answer, negative 3,267.44. Move it over there so it's off that little watermark so you can see it. Let me go back over your steps just briefly with you, okay? The first thing we did, number one, is we looked up the standard enthalpies of formation using the appendix. That's the first thing we did. Then what did we do? What's this line doing? Right. Multiply by the coefficients. And then right here, we took the sum of the reactants and we took the sum of the products. And then finally, we said products minus reactants. And that's the steps.